In this video, we are going to discuss one of the exercises in the John Bird textbook, Understanding Engineering Mathematics. We're looking at practice exercise 259, number 12, on page 714. So here we are given an integral, and we have to evaluate this integral, and we are using the method of algebraic substitution. Okay, so let's go ahead and evaluate this integral. So it is a definite integral, and we first got to find the indefinite integral. Okay, and then after that, when we find the answer, we are going to apply the limits of integration. So let's go ahead and work out the indefinite integral of this function, of this given function. So we have the indefinite integral of 2j plus 1 multiplied by e to the minus j multiplied by j plus 1 multiplied by h divided by 8 pi squared times I times k times t. This is, of course, an integral with respect to j. So we are using the algebraic substitution method. So we are going to let u be equal to the function inside the exponential, function. So we're going to let u be equal to this over here. Okay, let u be equal to this whole thing and see what we get. Okay, so let's go ahead and see what we get when we let u be equal to j. Let it be minus j. So it's minus, u is minus j times by j plus 1 times h over 8 pi squared multiplied by I multiplied by k multiplied by t. So we let u be equal to minus this. Then we go ahead and we differentiate. So this implies now that the derivative of u with respect to j, so we have to differentiate this with respect to j. So this is equal to the following. So now we're going to substitute, we're going to take out the constant. So everything that's constant, we're going to take it out of the derivative. So we take out the minus h over 8 pi squared multiplied by I multiplied by k multiplied by t. So we take that out of the derivative. Okay, and then we go ahead and we differentiate with respect to j. We differentiate j multiplied by j plus 1, which is the same thing as j squared plus j. Okay, now if we differentiate j squared plus j, we're going to differentiate the first term, which is j squared, and that's going to give us 2j plus the derivative of j, which is going to give us 1. So basically we get the following. Outside the derivative, we have this minus h over 8 pi squared multiplied by I multiplied by k multiplied by t. And the derivative is the following. It's 2j plus 1. Okay, there we go. Now we are going to cross multiply because we want to write dj. We want to substitute in place of dj. So we are going to write dj in terms of du. So we are going to cross multiply. Okay, so let's cross multiply so we can write dj in terms of du. Excuse me. So let's go ahead and cross multiply, and we get the following. We get that du is equal to can say let's divide over there. So we say du. We are going to divide du by this whole thing by minus h over 8 pi squared times I times k times t. Multiply this by 2j plus 1. So we divide du by all of this over here. And that is equal to dj. So divide both sides by this, multiply both sides by dj, and we get that this is equal to dj. So du over this is equal to dj. So we are going to go and substitute this into our integral there. We've made the substitutions. We're going to go ahead and substitute. So we say, therefore, the integral, okay, the integral of 2j plus 1 multiplied by the exponential function e to the minus j multiply j plus 1 multiply h squared divided by 8 pi squared multiplied by I k multiplied by t with respect to j. So now this integral is equal to the following. It's equal to the integral. We can write the 2j plus 1 in there, and then we're going to multiply this by e, but in place of this function we're going to put u, because we said let u be equal to that. So in place of all of this we're just going to put u, and in place of dj we are going to put du. In place of dj we are going to put du divided by minus h divided by 8 pi. Okay, let me go back. I'll go back. I want to write the pi properly. So we've got 8 pi squared multiplied by a k multiplied by t, right? Multiplied by 2j plus 1. So that is basically what we replaced a dj with, because we show that dj is equal to this. So now we have a new integral in terms of u. We can take out the constant, okay? So we can take out the constant, and of course minus h, or it's 1 over. Remember this is a one fraction here. So this is basically 1 over minus h over 8 pi squared IKT. So when you take it out as a constant, you can write it as 1 over minus h over 8 pi squared multiplied by I multiplied by k multiplied by t. So you can write it like this. It's 1 over minus h over 8 pi squared IKT. Take that outside of the integral because it is a constant. Everything else in the integral is not really a constant. So now we multiply this by the integral. And then we also note something before we write what's in the integral. We note that the 2j plus 1 cancels out with this 2j plus 1 here is on the top, and this 2j plus 1 is at the bottom, so they cancel out. So now inside the integral, what you are going to be left with inside the integral, you are going to be left with e to the power u, and you're doing this integral with respect to u. So you're going to be left with this. Okay, so here's your integral. Now it's nice and simplified. And you know that when you're integrating the function e to the u with respect to u, that will give you e to the u. So the constant outside, you can write this like this. You can write this as minus 8 pi squared multiplied by I kt divided by h. So you can write this constant like this. You can tip in times and write it like this. Same thing. And the integral of EU is the same as EU. So this is just the same. This is equal to EU here. It's EU. We're not going to put a plus C because we are evaluating a definite integral. We're just finding the antiderivative now. So this the result here is EU. And we have to leave the answer in terms of J. So we have to leave the answer in terms of J because the integral was given to us in terms of J, so we have to leave the answer in terms of J. And we said that U is equal to, go back, we said U is equal to this minus J times J plus 1 times H over 8 pi squared I kt. So we replace U with that in the answer. We go to the answer and we replace U with that, okay? So let's go back to the answer. Let's replace U with that. So now this is equal to minus 8 pi squared I kt divided by H multiplied by E to the U. And we replace U, of course, with the minus J into J plus 1 multiplied by H squared divided by 8 pi squared multiplied by I k t. And that's the answer. And this answer, though, this is the answer to the indefinite integral. We still have to apply the limits of integration to this. This is the answer to the indefinite integral. This is the antiderivative. So now we say therefore. Now we're going to write the final answer. We have to find the final answer. So we're going to say therefore the integral from 0 to infinity now. So now we're going to apply the limits of integration to this. So we say the the integral from 0 to infinity of 2j plus 1 multiplied by e to the minus j into j plus 1 multiplied by h squared divided by 8 pi squared multiplied by I multiplied by k multiplied by t, okay, with respect to j. So we got 2j plus 1 times e to the minus j into j plus 1 times h squared over 8 pi squared times I times k times t with respect to j. So this is equal to the following. It's minus 8 pi squared times I kt divided by h multiplied by e to the minus j times j plus 1 multiplied by h squared divided by 8 pi squared I kt, and we apply the limits of integration now, okay, which is from 0 to infinity. All right, so we do that, and so we're going to start with infinity, right? Let's start with infinity. So what this means is the following. So we can put it in square brackets again. We've got minus 8 pi squared multiplied by I multiplied by k multiplied by t divided by h. So you go e to the minus, and in place of j, put the infinity. And what this basically means is that it means that j approaches infinity. Obviously, infinity is not a specific number. It's unbounded. It means that j gets bigger and bigger and bigger without an upper bound. It becomes bigger and bigger and bigger. It approaches infinity. So we put infinity over here. We put infinity over there. We've got infinity plus 1. So we substitute infinity in place of j. And we've got h squared divided by 8 pi squared I kt. We close our square bracket and then we go minus. The same thing, we've got 8 pi squared multiplied by I multiplied by k over h, okay, multiplied by e to the minus. But in this case now, we are going to substitute 0. We've substituted the infinity, now we're going to substitute 0. When you substitute 0 into j, you get the following. You get j multiplied, well, everything is multiplied by 0 now. When everything is multiplied by 0, you get e to the minus 0, which is basically e to the 0. And you close your square bracket. Okay, so this is how you evaluate the definite integral. Substitute to infinity, and then you substitute 0. So now you have to deal first with the infinity. You have to deal with this over here. So how do you exactly deal with that? As I said, what this thing means here, okay, let me just circle it again. I'm going to circle this. What this thing means, this thing over here, what it means is, it means that your j value is approaching positive infinity. It gets bigger and bigger and bigger. And notice the minus here. This is e to the minus of that. So if we go to the side here and rewrite this, let's rewrite this on the side here. And let's just focus on what it means, okay? Let's write this on the side here and focus on what it means. We've got e, we've got minus infinity, okay, multiplied by infinity plus 1, multiplied by h squared divided by 8 pi squared, okay, 8 pi squared multiplied by I multiplied by k multiplied by t. So it's e to the minus this, basically. E to the minus of this, okay? Now, you can rewrite this as follows. This is the same thing as 1 over, just using the laws of exponents. Say same thing as 1 over infinity, e to the infinity plus 1 multiplied by h squared divided by 8 pi squared times I times k times t. So you can rewrite it like this. So you basically have 1 over e to the infinity, right? Because you've got one thing, you've got this j that keeps getting bigger and bigger and bigger. Okay, it's unbounded. Okay, it doesn't have an upper bound. What this actually means here, it basically means that you are basically finding, this is actually equal to the limit. Okay, if we are being explicit about what's going on here, what you're doing is that you are finding the limit of j. That's what it means. Okay, since infinity is not a specific number, it's infinity means that you're getting bigger and bigger. It's unbounded above. All right, so you've got e to the j multiplied by j plus 1. You've got h squared, which is a constant, of course, over 8 pi squared times I times k times t. So what you're doing here basically is that you are finding the limit of this function of 1 over e to the j times j plus 1 times h squared over 8 pi squared times I times k times t. You're finding the limit of this function when j approaches positive infinity. That's what this means. So when you break it down and you find the meaning of what this is, or find what this means, it means this. You're actually finding a limit here. The limit of this function as j approaches positive infinity. So what exactly is the limit of this function when j approaches infinity? Positive infinity, to be specific. Now, if j is approaching positive infinity, now you've got e to the j times j plus 1 times h squared over 8 pi squared I k t, and your j is getting bigger and bigger and bigger. Okay, what happens is that e to the power of this function here also gets bigger and bigger. This is, of course, assuming that I, K, and T are positive. Okay, so we assume that I, K, T are all positive. H squared is positive for sure because it's squared. So assuming that I, K, T are positive, as j gets bigger and bigger and bigger, e to the power of this function j times j plus 1 h squared over 8 pi squared IKT is also going to get bigger. All right, it gets bigger. It also gets unbounded. So as it gets bigger, obviously 1 over this e to the power j times j plus 1 times h squared over 8 pi squared IKT, 1 over that is going to get smaller and smaller and smaller. It's going to approach 0. It's going to approach 0. So as j goes to infinity, 1 over e to the j times j plus 1 times h squared over 8 pi squared IKT is going to get smaller, is going to approach 0. That's what basically this thing means. It means that we're finding a limit, and that this limit is actually going to is actually equal to 0. Okay, this limit is equal to 0. This, of course, assuming that I, K, T, or that I and K and T are all positive. If I and K and T are all positive, then the limit of this function as j goes to positive infinity is equal to 0. Okay, if we assume that I and K and T are all positive, then the limit of this function as j approaches positive infinity is equal to 0. Okay, and that's basically what this is. All right, so we can then replace, okay, we can come back here and replace this. We can replace it with 0 because we saw that it is actually equal to 0. Okay, so we replace it with 0. When we replace it with 0, we go 0 multiplied by this constant, so the whole thing is just 0. So meaning that the whole bracket here, this whole bracket here is 0. Because we multiply this constant by 0, so the whole bracket is 0. The whole thing vanishes. Whole thing vanishes. So therefore, that means the following now. That means this. It means if the whole thing vanishes, if the whole first bracket vanishes, then we have this. This is equal to the following. This here is equal to minus. Okay, before we write it down, let's just go back. Okay, note that we have a minus here outside, and there's also another minus here. Okay, note that. And also note that e to the minus 0 over here is just e to the 0. E to the 0 is 1. Okay, so also note that. So what this basically means is that what we have here is the following. We've got that this is equal to 8 pi squared multiplied by I multiplied by k multiplied by t at the top, and at the bottom divided by h. And that's the answer. That's the answer of our integral. Okay, so basically ZR is equal to that. So as a conclusion, we can say that ZR, as a conclusion, we can say, therefore, ZR is equal to 8 pi squared I kt divided by h. Okay, that's the final answer.